we are discussing on pavement material and its characterization. Previously we have seen the different types of pavement, that is flexible pavement and rigid pavements. Also we have seen the different layers we are forming to construct a pavement. Now our today's topic is pavement material. What are the material we are using to construct a pavement? The different layers consist different materials. So we are moving to the pavement materials. Okay, we can say we have basically four different layers. Starting with the bottom one is subgrade, the upper portion of subgrade, the next layer after subgrade is subbase, then after base layer, and then after the surface layer. So if we consider the subgrade, soil is the main constituents in subgrade and embankments. Embankment is a kind of natural subgrade. Okay, next, aggregates are used in the subbase and base layer. After subgrade layer, in the subbase and base layer, we are basically used aggregates of different size and shape. Now subgrade and the embankments, the basic function of this two layer is to provide support to the pavement. The whatever the load is coming on the surface of pavement, it is highly bared by subgrade and embankment. If your subgrade and embankment are loose, your pavement will not bear maximum load and it gets failed. So different types of failure also, such as rutting and showing in the flexible pavement, in which generally we use bitumen and asphalt in the flexible pavement, and also we have seen cracking in the rigid pavements which are made of concrete, are due to poor subgrade soil. So here we can say that subgrade soil is the crucial portion or crucial part of the pavement cross section. If we talk about pavement cross section, the subgrade and the embankment is the crucial portion on which we should go thoroughly to provide the strengthened pavement, the high strength pavement. So our next topic is subgrade soil. The pavements are a conglomeration of materials. These materials associated and their associated properties and their interactions determine the properties of the resultant pavement. So thus a good understanding of these materials, how they are characterized and how they perform, is fundamental to understanding the pavement. The material which are used in the construction of highway are intense interest to the highway engineer. Obviously this requires not only through understanding of soil and aggregate properties which affect pavement stability and durability, but also the binding material, such as we can say bitumen and asphalt, the binding materials which may be added to improve this pavement feature. So what they say is that not only soil and not only aggregates property which affect or which affect the stability as well as the durability of this pavement, but also the binding material also affect in durability and stability. But if we talk about subgrade soil, then the soil is an accumulation or deposit of earth material derived naturally from the disintegration of rocks or decay of vegetations that can be excavated readily with powered equipment in the field or disintegrated by gentle mechanical means in the laboratory. So this is what the subgrade soil is. The supporting soil beneath the pavement and its spatial undercourses is called subgrade. Undisturbed soil beneath the pavement is called natural subgrade, and the compacted subgrade is the soil that compacted by controlled movement of heavy compactors. So subgrade soil is also like natural subgrade and some compacted subgrade. Natural subgrade, sometimes we can say the kind of earthwork, okay, and compacted subgrades that is formed by different heavy compactors and the controlled movements of that compactors. So that is known as the compacted subgrade. So next is the desirable soil properties. Once if we look forward for subgrade soil, at that moment we should know what are the desirable properties of that particular soil or subgrade soil. So the desirable properties are, as a highway material we can say, the first is stability, minimum change in volume, permanency of strength, incompressibility, good drainage, and ease of compaction. So go thoroughly through these properties. Let's talk about stability. The resistance to permanent deformation under loads is called as a stability of pavement. If we talk about stability, there are a few factors which affect the pavement stability, and those are: first is vehicle and traffic. Next factor which affect the stability is moisture. Next is climatic conditions or climatic factors we can say, which include frost action by low temperature. Also soil factor which affect the pavement stability. This soil factor represent the type of soil, its bearing capacity, etc. And the last factor which affect the pavement stability is stress distribution. Stress distribution represent the function of pavement and base in transmitting the load to the subgrade. We can say the stability of subgrade can be improved by soil stabilization. Sometimes the thickness of various layers is increased to improve the stability of the pavement. When road is constructed in embankment, the factor of safety for slope stability should be 1.5. As per IRC recommendations, the side slope for road in the embankment is equal to the 1:2, where 1 is the vertical and 2 is the horizontal distance is required, while in cutting the slope of 1:1 or to the 0.5:1 is provided. So this is all about the stability of the soil, how the stability affect the soil property. Okay, next is minimum change in volume. Now, minimum change in volume will ensure the minimum variation in differential expansion and differential strength values. Expensive soils, or we can say like black cotton soil as an example, as a subgrade material are very poor, as these soils are very expensive in nature. Such soils all should be removed by excavation, and subgrade shall be prepared by granular soils, so that it will not allow the major changes in the volume of subgrade soil. So generally we used subgrade material as a granular soil. Yes. Next is permanency of strength. The permanency of strength, the subgrade soil must possess sufficient bearing capacity and shear strength. If applied stress on the subgrade is very low when compared to its bearing capacity, the deformation due to load would be elastic or fully recovered when the load is released. This is possible when the applied stress is very low. The formation of waves or corrugation and lateral shoving of pavement near the edge along the wheel path of vehicles is due to insufficient bearing capacity or a shear failure in subgrade. So if soil will have the permanent strength, then at that moment it will have, or it will give the sufficient bearing capacity to this subgrade, and also it prevents shear failure in the subgrade. So that's how the permanency of strength is very important for the soil. Next desirable properties is incompressibility. The property of soil due to which a decrease in volume occurs under compressive forces. This is known as compressibility of soil. That means when a compressive force applied on the pavement or applied on that layer, at that moment how much decrease in volume and how much the soil allows that force to compress itself is known as its compressibility. Yes, so incompressibility of soil subgrade is desirable as the compression of soil due to application of loads may cause differential settlement and the failure of the pavement surface. Next desirable property of the subgrade soil is good drainage. Good drainage is essential to avoid excessive moisture retention and to reduce the potential frost action. Poor drainage cause waves and corrugation. In some clayey soils, variation in moisture content cause considerable variation in volume of subgrade, which causing failure of pavement. If excessive moisture in soil subgrade, which cause considerable lowering of its stability, the pavement is likely to fail due to subgrade failure. So this is how good drainage is necessary in soil. The last is compaction is to ease of compaction. Now, ease of compaction ensures higher dry density and strength under particular type and amount of compaction. The granular soils can be compacted easily, giving higher dry density and the strength. So these are the desirable soil properties as a highway material. So our next topic is type of soils or soil type. Soil types can be categorized as laterite soil, murum soil, which is sometimes called as a red soil. Next, desert soil, desert sand, alluvial soil, clay soil, which including black cotton soil. Here, a Indian standard grain size classification is given, in which a gravel. The gravel are coarse materials with particle size under 2.36 mm with little or no fines, contributing to cohesion of materials. Next is murum soils, which is sometimes known as the red soil. These are the products of decomposition and weathering of pavement rock. Visually, these are the similar to gravel, except presence of higher content of fines. Next are the silts. Silts are the finer than sand, brighter in color as compared to the clay, and it exhibit little cohesion. Next is clays. Clays are the finer than silts. Clay soil exhibit stickiness, high strength when it's dry, and show no dilatancy. Also, the black cotton soil and other expensive clays exhibit swelling and shrinkage properties. Paste of clay with water, when rubbed in between fingers, leaves strain, which is not observed for silts. So these are the type of soils generally used or generally we faced when we are constructing a pavement. So because of the varieties and various type of soil, when we are constructing a pavement and we are forming the different layers, we should check or we should taste the soil properties. Okay, so to evaluate the strength properties of the soil, generally on site or in practical, we are performing different taste on the soils. So in the subgrade soil, we are basically perform three different type of taste. First is shear taste, second is bearing taste, and the third is penetration taste. Shear tests are usually carried out on relatively small soil samples in the laboratory. The bearing tests are loading tests carried out on the subgrade soil in situ or in site with a load bearing area. The result of the bearing test are influenced by variations in the soil particles within the stressed soil mass underneath, and hence the overall stability of the part of the soil stressed could be studied. The third is the penetration test. The penetration test may be considered as a small scale bearing test in which the size of the loaded area is relatively much smaller and ratio of the penetration to the size of the loaded area is much greater than the ratio in the bearing test. So this is all about the brief introduction or brief explanation of different types of soils.